To stay updated, subscribe to TJ Academy.
Bismillahirrahmanirrahim. In this video, we are going to discuss panel data analysis. Panel data analysis. For this purpose, we have to understand some basic concepts. Here, this is a simple regression model, and if we write this regression model with this T, so it means we are running or we are using the time series model. On the other side, if we use this regression model with this I, so it means our model is cross-sectional model. And if we use with I and T, so it means this regression model will be used for panel data analysis. So there are two main reasons why do researchers use panel data. Number one, if group wise or regional analysis is required rather than individual based. What does it mean? If we want to find some relationship between variables of textile industry, and we have to take all textile firms in our data, so it means we are going to analyze the whole industry. Or if we use all Asian countries to analyze the Asian relationship between the variables in Asian countries, so group wise or regional analysis whenever is required, so we have to use the panel data. The second important reason, if data is not enough for individual analysis. What does it mean? If each cross section or entity does not have enough data to analyze, so we have to pool or make a panel of similar firms or similar countries or similar cities to analyze the relationship among or between the variables. So there are two main reasons. Number one, if group wise or regional analysis is required, and number two, if individual firm or individual entity does not have enough data to analyze, then we will go for panel data. Now, the basic regression technique for panel data analysis. Number one, pooled ordinary least square or panel least square. Number two, fixed effect model, and number three, random effect model. These are three basic regression technique for panel data. Now let's suppose there are 50 firms of textile industry. Now, in pooled ordinary least square, when POLS is used, if all firms in the panel are more or less same in terms of intercept and coefficient. What does it mean? When we run this regression model for all our panel data, so we are assuming here the intercept and coefficients are same for all cross sections or entities or firms in POLS. What we consider? We consider all firms are having same intercept. On the other side, fixed effect model, if researcher consider all 50 firms in the model and assume that intercept of all firms is different due to different factors. I repeat, intercept of all selected firms is different due to different factors like their capital, like their production, like their investment, like their plant size, due to plant size. So due to these reasons, all firms having different intercept. So fixed effect model assume that all entities and cross sections have different intercept due to their in our case due to their capital, production, investment and plant size. So there are three methods in fixed effect model to consider the different intercept for each firms, like number one, within group fixed effect model, and number two, first difference fixed effect model, and number three, method, least square dummy variable fixed effect model to consider the different intercept for each firms. The most usable method. Here the least square dummy variable. First, this is a simple regression model. Y is the dependent variable and X is the independent variable. Here we consider two firms, firm A and firm B. These are the data for Y and X of firm A, and this is Y and X of firm B. As we have discussed above, in least square dummy variable procedure of fixed effect model. And what does fixed effect model do? Fixed effect model consider different intercept for each firms. So in fixed effect model, meaning in least square dummy variable, all firms have their dummy variables to show or to find the value of each intercept for each firms. Like here we have a dummy variable for firm A, so we are making creating a dummy variable for 1 for firm A, otherwise 0, and dummy variable of firm B, 1 for firm B, otherwise 0. So these are two dummy variables we have created for different intercept of both firms. Now if we incorporate these dummy variable in our model in least square dummy variable procedure, so here y is equal to alpha plus beta x. This is the simple model, but we have add here a dummy variable dA. So in the presence of this dummy variable, the intercept would be for firm A, and if we put 0 here, it means alpha shows in the presence of dummy variable of A. If we put 0 here, so it means alpha shows the intercept of firm B. And if we want to add all dummy variable in our model, so we have to exclude the intercept, as we have discussed in our dummy variable chapter, that if we add all categories of dummy variable in the model, so we have to exclude the intercept of the basic model. So here if we add all dummy variable here, dummy variable for firm A and dummy variable for firm B, so we have to exclude this intercept in this model. So this is the model of to analyze a fixed effect model with the least square dummy variable procedure. Now what does the random effect model do? Let's suppose there are 50 firms in textile industry, as we have discussed above. If researcher considers some selected firms in the model, let's suppose 20 in the model, and assume that the intercept of all selected firms, all selected 20 firms, is different, and random effect model assume that the difference in intercept is due to randomness of the sample. I repeat, in random effect model, the intercept of all firms will be different due to randomness of the sample, unlike as in fixed effect, which assumes that difference is due to different factors like capital, production, investment, and others. I repeat, in random effect model, all selected firms or entities having their own intercept, but this difference in intercept is mainly due to the randomness of the sample, unlike as in fixed effect model, which assumes that difference is due to different factors like capital, production, and others. Here if this is the model, y is equal to alpha plus beta x, and this would be the error term. Above model looks like a regression, and we can estimate through least square technique, but this is not the case. Here if we are applying the random effect model, so in this model alpha, here alpha shows the mean intercept for all cross sections or entities. If we apply the random effect model, so here alpha shows the mean intercept for all cross sections or entities. In random effect model, if we apply random effect model above, then ET, this error term, would be divided into two parts. Number one this, and second one is this. This part mu it is the same as in OLS following randomness, means no trend. This part of error would be random, but this sigma is different for all cross sections to get individual intercept with alpha. Means this value of each cross section and this mean value combine and shows the individual intercept. So I repeat, sigma is different for all cross sections to get individual intercept with alpha. It varies cross sectionally, obviously all forms having different values of this sigma, so it varies cross sectionally but constant over time for each forms. Now we can write our model for random effect model, like y is equal to alpha beta x, and the error term would be like this. Now how a random effect model works, or how random effect model estimates their intercept and coefficients. Consider the regression model y is equal to alpha plus beta x, or error term, and this is both are the error term. As we have discussed above, that we cannot apply OLS because of non-random part of error. We cannot apply the simple OLS in random effect model because of this non-random part, this sigma. Random effect model uses generalized least square. Here what is GLS? We can look the definition. GLS is OLS on the transform variable that satisfy the standard least square assumption. This it means when we apply Cochrane-Urquhart estimation procedure to remove the autocorrelation method, this would the method of Cochrane-Urquhart procedure would be also called a GLS, because in Cochrane-Urquhart we transform all variables to satisfy these standard least square assumptions. On the other side, in heteroscedasticity, when we apply weighted least square or WLS to transform our model and remove the heteroscedasticity from the regression model, the procedure would also called GLS. So GLS is OLS on the transform variable that satisfy the standard least square assumptions. Here we a random effect model will transform their variables by this part. So this is the manual procedure. So we will not discuss how the GLS would use, but random effect model works with the help of GLS. And after estimating the GLS, or after applying the GLS, the estimators thus obtained are known as GLS estimators. Means alpha and beta would be called the GLS estimators in random effect model. Now there are two type of fixed and random effect model, one way and two way. Above we have discussed the intercept is different for different cross sections or entities. This is one way effect. Means if researcher consider the different intercept for different entities only, this would be the one way effect. If researcher consider each time also have their own intercept, each time period also has different intercept. What does it mean? If we have taken the data from 2014 to 2020, so researcher consider 2014 has their own intercept, 15 their own intercept, 16 has their own intercept. So we will make the separate intercept for each cross sections with each period of time of. So in this condition, if researcher consider each time period also has different intercept, so this will be the case of two-way effect. In this case, we will say two-way fixed effect model or two-way random effect model. Now how can we select which technique is appropriate for our data among POLS, fixed effect model or random effect model? Which technique is appropriate for considered data? Now we are going to discuss the procedure to select appropriate technique. Number one, these are the steps. First, run POLS or panel least square. After running this simple regression of panel data on panel data, apply Breusch-Pagan test. Null hypothesis of Breusch-Pagan test is POLS is appropriate. Then fixed effect and random effect model, or no effect, means no effect on intercept of each forms. When we apply Breusch-Pagan test, if p value is greater than 0.05, then we will accept H0 or null hypothesis. It means then null hypothesis, it means POLS is appropriate and go for POLS. But if the p-value is less than 0.05, then reject H0, reject the null hypothesis. What does it mean? POLS is appropriate, and if it is rejected, so we will go for random effect model and fixed effect model. Now, after applying Breusch-Pagan test, and if we reject the null hypothesis of Breusch-Pagan test, we have to apply our third step, which is apply random effect model. Then apply fourth step, apply Hausman test. After applying random effect model, apply Hausman test. Null hypothesis of Hausman test is random effect model is appropriate. Then fixed effect model. If p-value is greater than 0.05, then accept null hypothesis and go for random effect model. But if p-value is less than 0.05, then reject H0. What does it mean? Random effect model is appropriate will be rejected, so it means we should go for fixed effect model. And after this, if the hypothesis of Hausman test will be rejected, so we have to apply our step 5, apply fixed effect model to estimate the regression. Now we are going to apply these procedures or these techniques in our model. Here, production is dependent variable, EM is number of employees, and OT is overtime are used as independent variables. Now, this is the procedure, and you have to copy paste. For applying the all steps. Selection among POLS, fixed effect and random effect model. Which technique is appropriate? First step, what is first run POLS or panel least square. So we all know, as we have discussed in our previous lectures, that for run the least square method, quick estimate equation, then first variable would be your dependent variable like production, then intercept, constant or alpha, and now you can write your independent variables. All independent variables means employment, number of employees, and overtime. So here the method is least square. So when we press OK, so this would be the result, or this is the result of our panel least square. In this method, we can say both variables have significant positive effect on dependent variable. These are the R square or adjusted R square, here the F statistics. So this is the result of panel least square, the first step. Now whether panel least square is appropriate or not, we have to apply Breusch-Pagan test, as we have discussed. So for Breusch-Pagan test, go view, fixed random effect testing, and Lagrange multiplier. Now this is the result of Breusch-Pagan test. Here for cross section, the value is significant. For time, the value is insignificant. What does it mean? It means we have to select one way random or fixed effect model. The time effect of intercept is insignificant. So this significant value shows POLS is not appropriate. Here the p-value is less than 0.05. It means reject H0 or reject the null hypothesis. What does it mean? If we reject the null hypothesis, we should go for random or fixed effect model. Here from here we can see there is only a one-way cross section effect, no time effect here on intercept. So it means, and both shows the significant result, which shows we have to run for our third step, and POLS is not appropriate for our model. For this we are moving towards our step 3. Now if the Breusch-Pagan test shows that fixed or random effect model is appropriate, now the third step is apply a random effect model. How a random effect model is applied? Go estimate. Now we are going to use this option, this tab, panel option. Click this option. Here the two tab here for cross section and for period. As we have discussed in our Breusch-Pagan test, the cross section having different intercept the result of cross section is significant and the period is insignificant. So in random effect model we have to select here is random only in cross section, not in period, and this would be the one-way random effect model. And when we press OK, this would be the result, and this is the result of random effect model. Here E means GLS, as we have discussed. Random effect model use the GLS, and E means error GLS, means transformation is applied on the basis of this non-random part of error. So this is error GLS, and this is the result. This is also shows the significant positive effect on dependent variable. Now here the intercept C shows what is, so as we have discussed here in our data there are 4 firms, and each firm is having 21 observation from 19 to 2000, and this intercept shows the mean intercept for all firms. Now if you want to find the value of intercept for each firms in random effect model, so go for view, random effect, random fixed effect, and cross section effect. So these are the individual intercept of each firms, firm 1, firm 2, firm 3, and firm 4. I repeat, if you have run your random effect model so this C shows the mean intercept values for all firms. But now if you want to know the intercept of individual firms, so go for view, fixed random effect, and cross sections. So this would be this will shows the intercept for each firms, firm 1, firm 2, firm 3, and firm 4. Now whether here random effect model is appropriate or not. So this apply Hausman test. This is our step 4. So consider this random effect model as a final result. Before considering this result as a final result, we have to apply Hausman test to confirm. Null hypothesis of Hausman test is random effect is appropriate, then fixed effect model. If p value is greater than 0.05, then accept H naught, which means random effect model is appropriate. And if p value is less than 0.05 of Hausman test, then reject H naught. It means random effect is not appropriate, go for fixed effect model. So for Hausman test we should go to view, fixed random effect testing, and this is the Hausman test. When we apply this Hausman test, this is p value is greater than 0.05. 0.05 it means we will accept the null hypothesis, and random effect model is appropriate. So this would be our final result. Now let's suppose if random effect, if Hausman test shows the significant result here, so what should we do? We have to apply fixed effect model for final estimates. Now just for the practice, we are going to apply the fixed effect model. For fixed effect model, go to estimate, select panel option, here select fixed effect, then press OK. So this is the estimates of fixed effect model, and fixed effect model also shows the positive and significant effect on dependent variable. Now there are slight, if you want to know the intercept of each firms in fixed effect model, so there is slight difference. You have to go to view random fixed effect model and cross section effect, but this result would not be the same as in random effect model. So first we have to freeze our result to get this value, and now go for view, fixed random effect and cross section effect. Now this and this both are not showing exactly the intercept of each firms, but we have to apply some calculation. Now if we open the calculator here, so to find the intercept for firm 1 in fixed effect model, we have to detect the value of this intercept ignoring the minus sign by this means here 5513.353 minus this value after ignoring the minus sign 23271.55. Now the minus 17.758 would be the intercept of firm 1. If we want to know the intercept of firm 2, 4576.611 minus 23271.55. Now the result is minus 18.694.939. This would be the intercept of second form. So, and you can also estimate the intercept of for firm 3 and firm 4. Now this is the procedure and the discussion on basic panel data analysis. I repeat, first we have to apply, I repeat these steps on selection of POLS and fixed effect and random effect model. First we have to run panel least square, then apply a Breusch-Pagan test. If Breusch-Pagan test is accepted, means POLS is okay. If Breusch-Pagan test is rejected, shows the hypothesis would be rejected, so it means go for fixed random effect model, then apply a random effect model. After applying random effect model, use Hausman test to confirm whether random effect model is appropriate or not. If hypothesis of random Hausman test will be accepted, so it means random effect model is appropriate. But if you apply, if the Hausman test shows the significant result, it means the hypothesis would be rejected and go for fixed effect model. And our fifth step, then apply fixed effect model to estimate the regression analysis. So this is the basic panel data analysis and their estimations. So if you find this video helpful, to please like and share the video and subscribe my channel TJ Academy.